Alright, hi, I'm Harrison.
I'm Kyle.
I'm Trenton Williams.
And this is 5-6 Graphing and Transforming Rational Parent Function Notes. The parent function for a rational function is the y is equal to 1 over x. An asymptote is a line that is a line on the graph that your lines that you plot will never touch, and it'll come super close. So that an example of this is
Line, crossing a line.
these two lines are your asymptotes. And see, these lines are going to come very close, but they will never touch. This is your horizontal asymptote, and then this is your vertical asymptote.
And
then this little circle out here is your point of intersection. The general equation for solving and graphing these is y equals a over x minus h plus k. A equals the stretch of the graph. H equals the left or right, and k equals the up or down part. Here's an example of a problem that you have to solve and then graph. So f of x equals 1 over x minus 3 plus 2. Now, draw your graph. This is your h, and this is k.
oh, I thought we were done.
And this is...
Hey, it's Trenton Williams back with some practice problems. Okay, here we got y equals -1 over x minus 6 minus 2. Alright, now we need to find the vertical asymptote and the horizontal asymptote, which is actually quite simple. To find our vertical asymptote, what we do is we look at the bottom of the fraction, and it looks like we got a -6, but we reverse the sign, which makes our vertical asymptote 6, and our horizontal asymptote is going to be the -2. Then we would go over here to our graph, and let's graph that. Now we are going to graph it. Here we have our vertical asymptote and our horizontal asymptote. And right in the middle where they meet is 6, -2. Now we are going to find our domain and our range. And what we do is for our domain, since it goes in the negative direction forever, we're going to have -infinity all the way to +6. And also, we are going to have 6 to +infinity. And now this is going to be our domain. And now, for our range, we're going to have, again, -infinity. We're going to have our -2 parentheses, very important. Now we're going to have our -2 and our positive infinity, just like we had up here with our domain. Now we have to determine if this is a negative or positive parent function. And how we do so is we look on top of the fraction, and we see here it is a -1, which means that this is a negative function.
Alright, so I'm Kyle, and we're going to do some parent functions. This is x equals 1 over x plus 2 minus 3. We are now going to find our vertical asymptotes and our horizontal asymptotes. We can already determine that these are -2 and -3 just by looking at them. Now we will graph them. We would next find a domain in the range. The domain is -infinity to -2, as -2 is to infinity, while the range is -infinity to -3, as is to -3 is to infinity. We will now determine if this graph is positive or negative. It is positive because there's a 1 and it is positive.
What? Waluigi, get out of here. I'm trying to do some algebra. Okay, back to 5-6 graphing, transforming rational parent functions. Alright, right here we have y equals 1 over x. And since we have nothing behind the fraction and nothing under it next to x, for our vertical and our horizontal asymptotes, they would both equal 0. Now it is time to graph it once again. Since our asymptotes are both 0, we would just plot the center of our graph in the middle, and we just have our points like this. So the y-axis and the x-axis would be our asymptotes. So now it is time to define the domain and range. Once again, it goes in the infinity direction, negative forever, to the 0 when it stops. For our other domain, it goes from 0 to positive infinity because it goes on forever. Now, for our range, it would be negative infinity to 0 to 0 to infinity. And we'd put our parentheses once again, and this would be our range and domain. And finally, to find out if this is a positive or negative parent function, we would look at the top of the fraction, and since we see it's just regular positive 1, good old 1, it is positive.
This has been 5-6 graphing transformation rational parent function practice with Kyle Pachaki,
Trenton Williams, and Harrison Prentice.